This is our third lecture of IP version 4 addressing and subnetting series. Plan of our series is given in this slide. In first lecture, we have discussed that IP addresses can be divided into two broad categories, classful and classless. While in second lecture, we solved example number 1, where default subnet mask is used. In this lecture, we will work on example number 2, where fixed length subnet mask is used. Before working on example number 2, we will work on subnet mask format. Now, if we convert a subnet mask into its binary, then all ones will be on the left hand side and all zeros will be on the right hand side. I will write a subnet mask in dotted decimal notation and then convert it into its binary format. As you can see in this example, all ones are on the left hand side while all zeros are on the right hand side. In this slide, you see some decimal number and their binary conversion. You are expected to memorize these decimal number into sequence 0, 128, 192, 224, 240, 248, 252, 254 and 255. When we work on their binary conversion, 0 means all 8-bit positions are 0 and 255 means all 8-bit positions are 1. If you look at 128, the leftmost first bit is 1 and all right side bits are zeros. If you see 192, on left hand side first two bits are ones and right hand side all bits are 0. So in the previous slide we discussed that in subnet mask all ones will be on the left hand side and all zeros will be on the right hand side. Having this information, we can say that in the subnet mask only these values can be used. In this slide we are going to convert between dotted decimal and prefix notation. 255 means 8 binary ones. Next 255 means 8 binary ones and next 255 means 8 binary ones and 240 means 4 binary ones over here. So 8 plus 8 plus 8, 24, 24 and 4 more. So slash 28 will be its prefix. In the second position, an invalid subnet mask is given and I'm writing its binary equivalent to show you and why it is invalid. You can see in its binary zeros and ones are mixed, while the condition is all ones should be on the left hand side and all zeros should be on the right hand side. So this is an invalid subnet mask. 255.255.192.0. So 255 means 8 binary ones and next 255 8 binary ones and 192 means 2 binary ones. Okay, you see here. And 0 means zeros only. So slash 18. 8 plus 8 16 and 16 and 2 18. 255 means 8 binary ones. 224 means 3 binary ones. 0 means all zeros, 0 means all zeros. 224 you can see over here. So 8 and 3 slash 11 is the prefix. Slash 27. Slash 27 we can have slash 24 if first 3 octets are 255. So I'm writing first 3 octets first, 255.255.255 and 3 more bits we required. So if we take 224, so 27 bits have been completed. 17 means first 2 octets are 255, means 16 bit positions have been occupied and one more, it means 128 and the last octet will be 0. Okay. Now we are going to solve example number 2 where a classful IP address is given. Classful means its network part is fixed. Means if it is class A, network bits will be 8. If it is class B, network bits will be 16. If it is class C, network bits will be 24. Okay, and full length subnet mask. Full length subnet mask will be explained when I discuss in detail example number 2 in the next slides. IP address is given and its subnet mask is given, and we have to determine following 8 values. So the first thing that we have to find out is class of given IP address. So to find out its class, we see its first octet. First octet lies in which range? Is it in between 1 to 126? No. Is it in between 128 to 191? No. Is it in between 192 to 223? Yes. It comes in class C. So the given network belongs to class C. Number of network bits. In classful IP addresses, network bits are fixed according to their classes. For example, if it is class C, it will have 24 bits. Number of host bits. To find out number of host bits, we count binary zeros in the subnet mask. This is the subnet mask given, and I am writing its binary equivalent. You can see in its binary we have 6 zeros, so number of host bits will be 6. Number of subnet bits, we have a formula 32 minus number of network bits which are 24 and number of host bits which are 6. So we got answer 2. Number of subnets, 2 raised to the power subnet bits, that is 2. So we got 4 subnets in this network. And the sixth point is number of host addresses per subnet, 2 raised to the power host bits. So 2 raised to the power 6 minus 2, so it is 62. See, in number 5 we calculated that there will be 4 subnetworks in this network, and each subnetwork will have 62 hosts. Look, for example, this is our first subnetwork, this is our second subnetwork, third subnetwork, and fourth subnetwork, and we calculated that each subnetwork or subnet will have 62 hosts. I took a grid of 8 by 8, so it has 64 total cells. In these 64, except these 2, all are filled with the computers, so there are 62 host devices are taken in this subnet. It is giving you idea that first subnet we can address maximum 62 end devices. Same as in the second subnet we can have 62 end devices. In third subnet we can address 62 end devices, and in the last subnetwork we can address 62 end devices. In the previous slide we saw that there are 4 subnets, so we have to give 4 subnet IDs. To calculate subnet IDs we need to determine octet of interest. Octet of interest is one from where the subnet bits are taken. Look, it is class C network, so the network part is first 24 bits, or you cannot take subnet part from there. From the last 8 bit, which is actually the host part, from where you will take the subnet parts, or you took the actually in the previous slides you have taken it. So the octet of interest is last octet over here, because from this one we took the subnet bits. So from 256 we have subtracted the value of the octet of interest, and we got the magic number 64. And now we will start from 0 and add the magic number in it. We got this value, and in this value again added the magic number, we got this 128. In this 128 we again added the magic number, we got 192. So these are our 4 subnet. So for example, first will be 0, the second will be 64, third will be 128, and the fourth is 192. Now I have listed subnet IDs over here. Broadcast address of subnet ID we want to to determine, we see the subnet ID of second subnet. It is 64, so the broadcast address of first subnet will be 63 minus 1. Subnet ID of third octet is 128, so broadcast of second subnet will be 127, and so on. For first usable address, we will look at the subnet ID, and we have added one. For example, 221.58.16.1 is the first usable address. We just have added one. We will see broadcast address for last usable address. Broadcast address is 63, so we have subtracted one, so last usable address is 62, and so on.